We continue to the next example called sections.asm. In this example, we are going to talk mostly about sections. Some of the material in this example was discussed before, but this time we are going to discuss the material in a more detailed fashion. Let's open sections.asm and see what is inside. As we can see, this time we have a full program, which means that if we assemble this program, we will really get an executable file, and not just a binary file, a flat binary file. Let's go over what we have here. We have data section, BSS section, and text section. We also have another section called iData somewhere inside training.inc. You shouldn't really care about it much at this point, but I wanted to note that it is there because we are soon going to open the executable file in a hex editor, and I don't want you to be surprised. Some general words about sections. Sections are just some way to divide the portable executable into parts. There is nothing really magical about sections. They are not something that the processor understands, for example. Sections are for the operation system. Basically, sections are just containers where we can put things in. In this example, we put some data inside the data section and some uninitialized data inside the BSS section and some code inside the text section, and so on. By the way, inside the iData section, we have references to some external functions that we can execute. Usually, every section is going to have some special purpose. This is not something that you should take too seriously, because you can really put anything inside any section. Usually, we are going to use the data section to put data inside, and the BSS for uninitialized data, and the text section for code, and so on. However, you shouldn't take this separation too seriously, as you can really put anything inside any section. You could, for example, insert some data inside the text section. Basically, the instructions are just data. Everything is really made of bytes. So this distinction to different sections is really artificial. You shouldn't take it too seriously. Some more comments about the special purpose of the sections. Some people think that the meaning of the section or the properties of the section come from the name. This is not true. The way that the section behaves really comes from the properties. For example, the data section has the properties data, readable, and writable. The BSS section only has the properties readable and writable. This is why the BSS section is for uninitialized data, and the data section is for initialized data. The difference is the data property. The text section, for example, has different properties. It has the code property, and also the executable property, which allow us to run code from this section. I want to emphasize that the name of a section does not matter. You could really change any name of any section to whatever you want. You don't even need this dot in the beginning. It is just a convention. If I wanted, I could change the name of the text section to be, for example, hello. As long as you don't pick a too long name, any name will work. The operation system doesn't care about it, and the processor really doesn't care about it. It is only made for human beings. I want to do a quick summary of the special purpose of every section in this program, just to make sure that we remember. The data section is used for initialized data. It means data that will also be kept inside the executable file. In this example, we have this special value stored in memory. You will usually put inside the data section data that the program is going to use, and mostly data that is important for the program operation. Maybe, for example, you could put some strings that you will show to the user, or maybe important numbers. The BSS section contains uninitialized data, which means that it only declares future space. It tells the loader, I want to have in the future 8 D words. Because the BSS section is only for future data or future space, you can't really initialize the data. Because if you did initialize the data, it would have to take space inside the executable file. There is no magic with data. It cannot come from nothing. If you want to have the data, if you want to have specific D words, for example, they will have to be somewhere inside the executable file. They can't come from nothing. Therefore, the data section is for important data that you want to show up later in the program. However, the BSS section is for keeping space, which is a bit of a different concept. In the case of the BSS section, we don't really care about the data itself. We only care about the space. Next, we have the text section. The text section usually contains the code. This is where our program runs. This is where we put the instructions that are going to run. The iData section, which is currently inside training.inc, is mostly for connecting us to functions in external modules or in external files. We are not going to discuss it at this point, but in the future we will see how to use it. The iData section, which currently is inside training.inc somewhere, is used for some kind of connection between our program and some other modules, or maybe functions in some other modules. As an example, we have exit process, which is really some function inside some other module. And magically, we can use it inside our program, using the iData section. We are going to discuss it later in this course. Basically, this program doesn't do much. It just prints one number as an example. We don't even need this part. At this point, I don't really care about what the program does. I really care about how it looks like on the disk. I want to see how it looks like inside the executable file. Let's assemble and run this program just to make sure that it really works and everything is okay. It seems to assemble okay. Now we can run it. In this example, we just did something really simple. We just printed the value num1, which is this label. And we got some number. Nothing is really special about this number. At this point, we can really delete this part because we don't really care about it. Let's assemble it again. And at this point, the program really does nothing. It will just exit the process, as we can see in those instructions. Let's see how the program looks like with a hex editor. This is really the interesting part. As usual, we have this header, and then this string about this program cannot be run in DOS mode, and so on. I'm going to align it to 8 bytes. It will help us understand a few things inside this binary. First, we can see that we have some kind of a table here. We can assume that this is a table because all those names, data, BSS, text, and iData, are really aligned. When things are aligned, it is probably a table. If we continue a bit, we will find some real data. For example, this part, where we can see 1, 2, 3, 4, 5, 6, 7, 8, is really some part of the data section inside the code. It is really array 6. Let's continue a bit. As expected, there is no trace for the BSS section. Really because it is uninitialized data. It would be a problem if the BSS shows up here. It would be incorrect. Next we have this chunk of strange bytes, which is probably the code. If you are surprised how come we have so many bytes, that is because the bytes you see here belong to training.inc. If we continue a bit, we will also find a bit more data. This part belongs to the iData section. We know it because we can see names of strange files, which are probably external files which we take functions from. And this is about it. Pretty simple. I want to discuss a bit more the table that we have initially seen. We managed to recognize those parts, the names of the sections. Maybe we will be able to guess the meaning of those numbers which we have here inside the table. You might be asking yourself, how could we guess those numbers? Those are just strange numbers. Well, we are going to think. We are going to think and compare some numbers until we are going to understand what those numbers are. This is a pretty important skill that as a low-level programmer, or just as a low-level somebody, you should strive to acquire. It is really important to try to understand how things work. So let's begin. The first part is probably just the name of the section. This is something we already know. Maybe you have never seen before a representation of text by hexadecimal bytes. Don't worry about it. This is something we are going to discuss in the future. For now, just believe me that it is possible. There is some way to encode text as bits, just like we have here. Then we managed to understand the first 8 bytes of every entry in the table. Next we have this D word. 18 followed by 30 bytes. What does this D word mean? We already know that we are dealing with the x86 architecture, so we probably should take it in the little endian convention, which means that this number is really 18 in base 16. In the BSS section we have 24. Let's try to guess what is this number. Inside the data section we have R6 defined, and it is made of exactly 6 D-words. I remind you that 6 D-words are exactly 6 times 4 bytes, which is 24 bytes. 24 is exactly 18 in base 16. If we continue to the BSS section, there we have declared num1, which is just 1 D-word, and then another 8 D-words, a total of 9 D-words, which is 36 bytes, which equals exactly 24 in base 16. It would be pretty convincing to assume that this number is the real size of the section. And by real I mean the amount of data that we declared inside the section. Or maybe the section's content size. At this point, we know what is the first D-word. Let's continue to the second one. What is the second D-word? We can see that it increases in some way. If we take it in the little endian convention, this D-word equals 1000, and this one equals 2000. The next one at the text section equals 3000, and so on. We have already seen this 1000 offset previously. We have already seen, for example, that the data section once had the size of 1000. So maybe, only maybe, this part is just the offset from the loading address. Which means that if the program is loaded at location X in memory, then the data section will be loaded at X plus 1000. And the BSS section will be loaded at X plus 2000, and so on. But this is just a guess. We haven't confirmed it yet. We move on to the next D-word, which is the third D-word. In the data section, it has the value 200, if we consider the little endian convention. In the BSS section, it has the value 0. Interesting. For the text section, it has the value 200. And it also has the value 200 for the iData section. The BSS section is the only section where this value equals 0. Maybe this D-word represents the size that the section takes inside the executable file. In other words, the section's size on the exe. This might be an interesting guess. Let's continue to the next D-word. In the data section, the next D-word is 400. In the BSS section, it is 600. In the text section, it is also 600. And in the iData section, it is 800. $400, for example, is not such a large number. Maybe it could be an offset inside the executable file. Let's try to follow it. Let's try to go to offset 400 inside this file and see what we have there. Currently, by the way, we are at offset 18C. We can see it here. In order to go to offset 400, we can just press Ctrl plus G and then write down 400. We can see that we got exactly to the beginning of the data section. If we try the same, for example, with the text section, with this D-word, which contains 600, let's try to get to location 600 inside the file. We get exactly to the beginning of the text section. A good guess would be that this D-word is the offset of the section inside the executable file. An interesting thing to note is that the BSS section and the text section begin at exactly the same offset inside the executable file. How can it be? The answer is simple. The BSS section takes exactly 0 bytes. Therefore, it is possible that the BSS and the text section begin at exactly the same location, at location 600. Basically, if we take this D word, which is the fourth D word, and add it to the third D word, we always get the fourth D word of the next section. Because this D word is the section size on the executable file, and this D word is the offset. So to get the next offset, we have to add the current offset plus the size. In this example, 400 plus 200 equals 600. And in the BSS example, 600 plus 0 equals 600 again. Let's continue this. In the text section, 600 plus 200 equals 800, which is exactly the beginning of the iData section. These are just a few guesses that we did, and it gave us a lot of information about the contents of the executable file. We have also seen that the BSS section is really 0 inside the executable file. It contains nothing besides this entry on this table. It doesn't take any more space inside the executable file, which is really cool. We only discussed the structure of the portable executable a little. If you ever want to learn more about it, you could research it on your own. There is really lots of material about it. Just search for portable executable format, or maybe PE format. This is what I wanted to tell you about sections. I'm going to see you in the next lesson. Goodbye.